All right, on this first one, we're recognizing that we've got a difference of two terms because we're subtracting. And we also recognize with the two terms, these are perfect squares. So this is an example of a difference of two squares. If it's a difference of two squares, what we do, set up the factorization for two binomials. First term in each of the binomials is the square root of the first term here. So square root of x squared is just going to be x. In the last positions, you're just taking the square root of the last value here. So square root of 16 before. 4's go in the last positions. And then we just have to remember, on a difference of two squares, the signs in both of the sets of binomials will be opposite. So minus plus or plus minus. You're done with that factorization. And again, if you want to check, you could FOIL that back out. If you FOIL that back out, you get back to x squared minus 16. Now in the second one, for the second one, we've got a sum here. And we've got a sum of two terms that are, again, perfect squares. There is no such thing as a sum of two squares as a factorization. So this guy, we cannot factor. This guy is prime. Okay, next one. Got another difference here. As we look at this difference between the two terms, these two terms, well, they're perfect cubes, right? We know that because if I take the cube root of x cubed, I get x. If I take the cube root of 8, I get 2. So with that understanding, to set up this factorization, you start with a binomial. In the first position, you got that cube root of x cubed, which is x. In the second position, you've got that cube root of 8, which is 2. And since we start with minus here, we got minus here. Now, building off of the two terms that make up this binomial, we set up a trinomial expression, where the first term over here is going to be this first guy squared, so x squared. And the last guy over here is going to be this last guy squared, so since we're squaring it, plus 4. The middle arrangement is the product of the 2 and the x. This middle term is 2x. And the sign on that 2x is going to be positive. There's your factorization for a difference of cubes. And notice this part right here, this quadratic form right here, looks like something maybe we could factor further, but we actually cannot. Okay, so on the last one, you've got a sum. The sum of squares, we can't factor it. But for this one, we've got a sum of two perfect cubes, right? You can take the cube root of 27. You can take the cube root of x cubed. You can take the cube root of 64. So we can take the cube root of all that. We'll start in a similar fashion to how we did the preceding one. We take the cube root of 27x cubed. Well, the cube root of 27 would be 3. X cubed would be x. So that's going to be the first term in this binomial expression I'm setting up currently. Since this is plus, it'll be plus right here. Cube root of 64 is 4. So the two terms that make up that binomial lay the foundation now to help me set up the rest of this trinomial expression that follows. Because I'm going to square the 3x, that'd be 9x squared. I'm going to square this 4, make that plus 16 here. And in the middle term, you're multiplying these together. So that's going to be 12x when I multiply that together. And then the sign is the opposite of what I'm starting with over here. It'd be minus 12x. Okay, so 2x squared minus 50. If we're kind of in this special factorization mode, we're looking at the minus sign here. We're seeing that difference. We know there could be some possibilities because of that difference. I do see an x squared here, so I know that's a perfect square. However, 2, 50, not perfect squares. So can't factor this as a difference of two squares maybe yet. What I can do, though, using that first rule of factoring, is I can factor out a 2. A 2 is the greatest common factor between these two values. If you take a 2 out, as far as what's left over, well, there's got to be two terms left over because I'm starting with two terms here. 2 goes into 2x squared, you're left with x squared for the first term. Then it's minus. 2 goes into 50, at 25 left. So factor out the greatest common factor. Now, if you look at what's remaining here, this x squared minus 25, that can be factored further because that's a difference of two squares. 2 in front, that has to come along for the ride here. That's still part of our answer. We know the x squared minus 25 factors to two binomials here. First term in each of these is the square root of the first term up here, so x. Last term in each of these is the square root of this last guy here, 25, so 5 and 5. Since it's minus, change the signs down here, make them minus plus or plus minus. There's your complete factorization for 2x squared minus 50. So on the second one, you got 12x squared minus 12x minus 24. Is there a greatest common factor between those three terms? Largest number that goes into all those. What is it? 12. So you take a 12 out. You take the 12 out. 12 goes into this first term, you've got x squared left. 12 goes into the second term, you've got minus 1x left. 12 goes into this last term, you've got minus 2. Now with the x squared minus x minus 2, this takes us back to the last lesson. You've got this quadratic form here. Maybe you can reverse the FOIL process to come up with a factorization of x squared minus x minus 2. So recalling how we did that, remembering how these terms match up with FOIL, right? These first terms down here have to multiply to give me this x squared. Only way that's going to work, x times x. These last values here have to multiply to give me 2, right? Because that's the L in FOIL. So the only way I'm going to be able to multiply and get a 2, it's got to be 2 and 1, right? Now it's a matter of getting the signs correct. If I'm getting a negative 2 back, these signs have to be opposite. If I'm trying to get a negative 1 back, outside is 1x, inside is 2x. Is it possible to get to a negative 1 from there? Well, 2x and 1x, if you take 2 minus 1, you get 1 back, right? You make that a negative 2 and make this a positive 1, then you've got negative 2x plus 1x, which will give you that negative 1x back. There's your factorization. All right, so we bring this last one over. You got x to the 6th minus 1. Okay, you got two terms you're subtracting. There's a couple of ways we could do this because as you look at these two terms, when you're subtracting, you're thinking difference. If you're thinking difference, the two possibilities that come to mind would be difference of squares or difference of cubes. Just so happens we've got both here. You could take the cube root of x to the 6th because the cube root of x to the 6th would be x squared. You could also take the square root of x to the 6th. The square root of x to the 6th would be x cubed, right? So it really doesn't matter how you start this one. If you want to treat it as a difference of two squares, we could. If I treat it as a difference of two squares, well, as I was saying, you know, from before, you've got two binomial expressions you know that are going to create this difference of two squares. And when you take the square root of this first term, x to the 6th, you get x cubed. So that square root of that first term goes in the first positions over here. Since we're working as difference of squares, take the square root of 1, get 1. That goes in the last positions. And then we attach the minus plus or the plus minus combination to complete that factorization. If you look at what remains in these two factors, we've got two special products again, right? This is a difference of cubes. This is a sum of cubes. So we could take this first part, breaking that down as a difference of two cubes. We know we start with a binomial expression. Cube root of x cubed be x. Cube root of 1 be 1. It's minus, so minus goes in between. These two terms set up our foundation to help us build the trinomial expression that follows. In that trinomial expression, we're squaring this first term here to get x squared. We're squaring this 1 here to get a plus 1 at the end. And then we multiply the 1 and the x to get 1x. Since it's minus here, it's plus there. Everything I've written out so far, that's the factorization for x cubed minus 1. As far as the factorization for x cubed plus 1, it's basically the same kind of stuff, right? Same kind of values involved. We know this was x minus 1, so since it's x cubed plus 1, it has to be x plus 1 here. And if we know the trinomial expression right here gave us an x squared, an x, and a plus 1, because I got a plus sign here, it's going to be a minus sign there. So everything for this part is the factorization for x cubed plus 1. At which point you ask yourself, are there any of these four pieces that are left over that you can factor further? And the answer is no, because these little quadratic forms that are provided here, those are not factorable. This is as far as we can go with this problem.